Welcome to QoE-Net OSC 4. The title of today's presentation is Current and Emerging Standards, SID, or as you can see, Information Display Measurement Standards. The expected duration of the presentation is 1 hour. Before we start, I need to point out the way of comments and questions for today. Instead of the regular verbal questions after the presentation, questions will be submitted via the public chat function located on the left side of the screen, which then will be addressed by the presenter. So if you have a question, you can immediately write it on the chat and it will be answered after the presentation. Dear presenter, the floor is yours.
Thank you very much for the introduction. So my name is Peter Kovacs, and today I'm going to talk about the Information Display Measurement Standard. During the preparation of this presentation, Joe Misali was of great help, who happens to be the chair of the ICDM, which is the body preparing the Information Display Measurement Standard. So I truly hope that today you will get the most accurate information possible about this standard. So I wanted to start with some reasons behind the creation of this standard. So as you can see in these quotes that I have found about different metrics and different numbers that are quoted in the specification sheets of different displays, people tend not to really believe in the contrast ratios or the viewing angles or the response times or other metrics that are often quoted by the display manufacturers. And the reason is that the way these metrics are measured are, well, at least in the past, were kind of arbitrary. So they were basically used as a marketing tool by manufacturers. So whoever has the highest number can say that, hey, I have the best display possible. And because these properties of the displays are important from the quality point of view, I thought that in a project which is basically dealing with the perceived quality of visual content, it is important to know that there is in fact a standard for measuring all kinds of different properties of standards different properties of the displays, which will ultimately determine the quality of the terminal device, which has a major effect on the perceived quality of whatever content we are looking at. So a few words about SID. SID is the Society for Information Display, which is basically a professional society founded in 1962. And in the name, this display refers to electronic displays. Now, the activities of SID mainly include publishing technical journals about displays, for example, the Journal of the Society of Information Display, the Digest of Technical.
Peter, sorry, I'm terribly sorry to interrupt you, but it seems you are having issues with your microphone. A sudden noise has appeared and your volume has suddenly dropped. I am terribly sorry for the interruption, but I thought it was necessary to point it out. Could you say something now to see if it's better?
Is it better now?
Actually, no, it's the same. It has suddenly dropped roughly 20-30 seconds ago, and we don't know why there's a noise. But as you can see it on the public chat,
Yeah,
it's quite irritating to the audience. So let us try to fix it, do something about that.
Is it better?
Not really. What does the audience think?
Can you hear me better?
Now it's okay, I think.
Okay.
Now it's all right. Okay, sorry again for the interruption, and please continue.
Okay, so As I said, the SID is publishing technical journals of technical nature, which are of interest for the for people working with displays, as well as they run conferences. The most famous of which is the Display Week, which is organized every year, as well as there are regional conferences like the Euro Display, which could be familiar to some of you, as well as they are dealing with emerging themes like vehicle displays and interfaces, and they have a separate event for dealing with those ideas. And a quite new activity that SID is taken up is standardization, and this will be the topic of the presentation today. So just for your information, where the ICDM is located in the hierarchy of the SID. So this is going to be the new governance structure of SID, starting from the beginning of the new year. And as you can see, part of the SID is the Definitions and Standards Committee, part of which is the International Committee for Display Measurement. Before that, so even today, the governance structure is like there is an executive committee with the president, president-elect, 3 regional vice presidents, treasurer, secretary, and the past president, and any 4 members of this executive committee constitute a quorum. This is important because you will see later on that they have to approve the standard that I'm talking about. So about the other committees, which gives you an overview of what other activities the SID is having. So there are academic efforts, chapter formation, the definitions and standards, which I mentioned, honors and awards, conventions, long-range planning, membership nominations, and publications. So this is just for giving you the overall picture, but we will focus on the definitions and standards committee, part of which is the International Committee for Display Metrology, ICDM, which is made up of over 300 display metrologists and specialists in display-related ideas, who run this joint activity of producing a standard for measurement and evaluation of displays in a uniform and consistent manner, so that they address this problem which I mentioned during the beginning of the presentation. And the name of this standard is the IDMS, the Information Display Measurement Standard. And the ICDM is running this activity in cooperation with VESA, which is the Video Electronic Standard Association. So what the ICDM done so far for the industry, basically produced the most widely used display measurement standard which was written to date, and also provided tools, so it's not just a standard, to obtain the performance metrics of different displays. And currently the ICDM is working on the next version of the standard, so they didn't stop because there are always new activities and new topics in the display field. So for example, manufacturers have gone beyond this RGB striped pixel format, so the measurement methodology also needs to address different pixel structures. Then there is still debate going on about the contrast ratio, like which method to use when quoting the contrast ratio of a display, as well as with the emergence of high dynamic range displays, metrology for these kind of displays should be developed as well. There are some issues about data formats related to displays which should be unified as well. They are also working on improving the metrics describing the reflections of displays, as well as working on reforming the specification sheets and giving recommendations for the industry, which is something that I'm going to talk about later. So the display measurement standard itself was first published in 2012. And as I said, SID is quite a newcomer in terms of standardization, because this is the first standard which was published by the SID. So the IDMS is the follow-up of a previous display measurement standard, which was called the Flat Panel Display Measurement Standard, which was originally created by VESA. The document consists of two parts. So first there is the main document, which is describing the different measurements, and then there is a set of test patterns that one can use to execute the measurements described in the document. The current version is 1.03b, but it only got some minor changes from the original version. This version of the IDMS has been approved by both the ICDM voting members and the SID Executive Committee that I described before. And the standard as well as the test patterns can be downloaded free of charge from the internet from this website icdm/sid.org.
Peter, it seems that we cannot. Now we can.
Okay. So the IDMS document is quite extensive. It's more than 500 pages, consisting of 26 chapters in total, 18 of which is about measurement. And in total it contains 237 different measurements for obtaining different properties of displays. Oh, okay. So the second version of this standard, which the group is currently working on, is likely to appear in 2017. So about the rules of the ICDM itself, there is a document called ICDM Rules and Procedures. So members of the ICDM are basically individuals who are somehow active in the field of display evaluation, and can be a member of this body basically by attending the ICDM meetings at least one per year, or actively contributing to the creation of the standard. Being a member of the larger body SID is not required, but is strongly encouraged. And by having individuals in this body, they had to make sure that that a bigger company is not having the majority of votes. So each company, academic institution, agency or consultancy has a single vote, and there is one individual representing that body when there is a voting. So according to these rules, contributing to the standard is basically, there is a low barrier, because individual SID membership is $100 a year, but even this kind of membership is not mandatory to contribute to the standard. So it's not as expensive to contribute like some of the other bodies. And about the voting status, sections of the standard are ratified if they get more than half of the votes of the eligible entities. So then they will be included. And the ICDM is warmly welcoming anybody who is a professional in display evaluation to contribute to the standard. Now about the top members of the ICDM. So the chair is Joe Mizzoli, who is a display metrologist. The editor is Ed Kelly, who is also a display metrologist, previously working for NIST. Secretary is Dave Schnuel from Dolby, and you can see that the vice chairs are also from well-known institutes. And then the Executive Committee of the ICDM consists of the Chair, Editor, Secretary, as well as the Chair of the SID Definitions and Standards Committee, as well as 2 more members from the ICDM. And the Executive Committee is basically responsible for resolving any disputes about the interpretation of the rules, appointing the chairs of the subcommittees that I'm going to talk about later, as well as voting for officers, documents, rules, and whatever. So the communication within the ICDM basically happens through emailing lists as well as face-to-face meetings. So there are 2 different mailing lists. One is for the active members list who get all the communication, and there is an interest list for those who are not interested in the daily work of the body but want to see what updates are available. And the meetings, usually there is an ICDM meeting co-located with each display week event every year. But as you can see, on top of that, there are other meetings, longer meetings that are dedicated to the development of the standard. The meetings which are co-located with the display week are rather about introducing new topics which might be of interest for the ICDM, and in those meetings there are usually presentations about novel topics related to novel display technologies. So there were presentations about holographic displays, speckles in laser projectors, curved displays, HDR, and so on. So the ICDM itself consists of subcommittees, and these subcommittees usually correspond to sections in the final document. So from this you can get an idea of what kind of measurements are included in this standard. So there are fundamental measurements, grayscale and color scale measurements, spatial, viewing angle, uniformity, temporal, reflection, motion artifacts, measurements related to projection, as well as 3D and stereoscopic displays, and the recent addition was the touchscreens and surface displays. And me, coming from Holographica, we're mostly interested and active in the 3D and stereoscopic display section, so I will emphasize some topics from there. There are also some working groups which are not closely tied to the subcommittees. So as I mentioned, there are already measurements described in the standard, but it's still not exactly clear which, for example, which one of the many contrast definitions a manufacturer should be using when quoting the contrast ratio of a display. So the purpose of this specification reform working group is to select for which kind of display which measurements should be used with what 3 variables, when there are 3 variables in the measurement, and then consumers should be able to compare one contrast ratio with the other and make sure that if it was done according to the IDMS standard, then this is a comparison between apples and apples. So this is basically the target of work group 1. And there is another work group which is working on just noticeable difference. So here they are about to derive a consensus on using just noticeable difference in ICDM works and the IDMS itself. And just to show you some examples of what kind of measurements are included in this standard. I've taken some of the ones which were interesting to me, and I hope they will be interesting to you as well. At least more interesting than the governance structures and voting procedures. So, for example, here is a measurement from section 9, which is measuring how the luminance of a display is changing when observing the screen from different viewing angles. So here, what is described, as you can see, all the measurements have a standard layout. So there is always a description, a procedure, analysis of the measured values, what needs to be reported, and usually there is an example output of how typically the result should look like. So in this case, what is described is that the person doing the measurement should be having an LMD, which is a light measuring device, and one should apply a full screen color onto the display, measure the luminance at the normal direction, so basically right in front of the display, and then one should measure the luminance change when rotating the LMD in front of the display, and report these values in a chart or in a diagram, like on the example shown below. Here is another metric which is often quite contradictory, which is response time. Because when manufacturers are quoting response time, they usually tend to forget to mention what they really mean by saying response time. So here it is exactly specified that the response time should represent the time, the rise time and the fall time. When you get a display, you point the light measuring display on it, and then from full black to full white you should make a transition and measure the time from the 10 to the 90%, and then another one from the 90% to the 10%, and add these two together, which sounds simple enough. But it is important to note that it is not from 0 to 100, and it is not just from black to white or just white to black, but the two together. I can see there is a question coming. Yeah. What is the temporal resolution of LMDs? Well, it basically leaves this to you. Like here it says in the other setup conditions that you should use an LMD with adequate time to resolve the response time, say 10 times faster or more than the fastest response time to be measured. So it doesn't say what it should be. It just says that it should be 10 times faster at least, so that you are not losing any data during the measurement. Is this enough? Okay, good. Okay, so one may think that this is all about response time, but turns out that it's not. Because if you look at this other measurement, which is gray to gray response time, you will realize that it is explicitly stating that LCDs, in case of the LCDs, it can very well happen that if you are measuring the transition time or response time from black to white or white to black, then it's not necessarily the same when compared to jumping from one level of gray to another level of gray. So because of this, it makes sense to create a matrix of different gray levels from where the transition and to where the transition is going. And as you can see from both the table and the chart above it, there are quite huge differences in terms of the response time. So this is just to make clear that that what we are measuring is really impacting the response time that we are reporting. Like, one manufacturer may choose to cherry pick such transition which has the smallest response time. But if they are reporting this full chart, then it should make clear what is really happening in terms of response time in the display. Then here is another interesting one, the residual image, which you may remember from the CRTs, but it may still exist with some technologies. Here you can see that there is a warning saying that it is possible to diminish the display. Like, what is happening here, it's I would say nothing special. So it's basically burning in a checkerboard pattern after measuring the initial state of the display. And here burning in this pattern is measured in hours. And then you check after this burning period, is there any residual image on the screen, and then you can basically report the amount of this residual image. And then you may want to fix the display, but as it says there is no set way to recover from a residual image, please contact the manufacturer for a suitable technique to remove the residual image. But there are other kind of interesting measurements, like how much weight can a display handle on the screen surface and so on, which might be of interest in some use cases at least. And then in the 3D and stereoscopic section, there is a whole section devoted to how the glasses should be handled when measuring stereoscopic displays with glasses, like whether you have the LMD fixed and moving the glasses, or you have the glasses fixed and you're moving the LMD, or you have the glasses fixed and then you are rotating the LMD. But the main point here is that the LMD should always see what your eyes are supposed to see, regardless of the technology which is used in the glasses. So it is explicitly talking about passive glasses and active glasses, but no matter what, the measuring device is supposed to see what you are seeing. So one of the criticisms that the stereoscopic displays often get is that they have crosstalk between the left eye and right eye. So there is, for example, a specific measurement for measuring the crosstalk, which, as you can see from the procedure, is basically doing what? It is measuring the level of white intensity when you have a white and the left a white and a black image, and then it is measuring the black when you have a black and white image, and then again it is measuring black when there is a black and black image. So it can quantify if there is a difference between the black level which is observed when the other eye is also black and when the other eye is white, because this is what crosstalk means, that you have some image intensity coming from the other eye. And then the other thing is reported for the other eye. So it looks reasonably simple, I would say, but still it is important that when you are reporting a percentage, or you are reporting it as a number like the extinction ratio, then we know exactly what have been measured and how it has been measured. The same crosstalk effect is often criticized in connection with auto-stereoscopic displays without glasses. So here the procedure of the measurement is very similar to the glasses-based stereoscopic display, but here, as you can see it from the description and the procedure. It is basically taking into account where the designated eye position is, so that you have to take care that the LMD is positioned exactly where the eye is supposed to be positioned, as well as it takes into account the usual interpupillary distance, so that during the measurement you can be sure that the light intensity that you are measuring will match with what the eyes would see. But other than that, the measurement is very similar to the previous one. Then here is one measurement which is quite interesting when considering different kinds of auto-stereoscopic 3D display technologies. Like in stereoscopic displays, you don't have anything like angular resolution, because there the left and right images are separated with glasses. But when you are considering auto-stereoscopic displays, then the viewer could be interested in how fine the change is between the different viewing angles when moving in front of the screen. So this is a metric that you can use against multi-view auto-stereoscopic displays, as well as parallax barrier displays, as well as light field and holographic displays, and then you can do a fair comparison of the smoothness of the change that you can see when observing motion parallax. So here again the measurement is actually pretty simple. Like you have the display, and you have the LMD positioned in front of it, and during the previous measurement, because there is also a measurement for determining the viewing angle of the display, but for this measurement we already assume that we know the viewing angle of the 3D display, and then we are projecting an image so that we are projecting basically peaks for odd and even views of the display, and rotating the LMD in front of it, and then we do the opposite, and we count how many peaks can we find inside the viewing angle, looking at the graph which we have captured by rotating the LMD and measuring it at different angles. And this basically gives us the angular resolution if we divide it with the viewing angle. Okay, so the IDMS also contains some reporting forms and templates for reporting the results of these measurements, a sample of which you can see here, which is an Excel sheet which will also do some automatic calculations for whoever is doing the actual measurement. So just to make things as easy as possible. And as I said, it also contains test patterns. So there are 80 native format test patterns available from the website, which is mentioned here. Again, free to download for everybody. And for each resolution, there is a zip file containing 1.2 thousand different patterns, ranging from very small resolution up to 4K resolutions. Some examples of which you can see on this slide. So, for example, there are alignment patterns. There are all kinds of simple solid color patterns, as well as gradients, as well as colors which are somehow special because of different display technologies might handle them especially. or other patterns about which are showing line patterns or dots or text patterns, so that one can use these to to measure the alignment, or for example some temporal instability of the display using these. What is important is that not that these patterns are difficult to make, but that everybody is using the same patterns for the same measurements. As well as there are some 3D test patterns, both the stereoscopic and auto-stereoscopic test patterns. This one visualized on this figure, we call it the hedgehog. This test pattern was contributed by us. And what is interesting about it is that the spacing of these pipes is uniform across the sphere. And having a suitable 3D display, you can watch through these holes, so that you can see the opposite side and you can see the gradient looking through these holes. And it is provided in many different formats, so that one can watch this pattern on all kind of imaginable 3D displays. And this will be online soon as well. Again, I can see that the question is coming. The question is, are there 3D test patterns for virtual reality head-mounted display? Not that I know of. Well, there are stereoscopic test patterns, but I mean, with a single stereo pair, you can't do much in a virtual reality environment, I guess. So I would say there are none at this moment. But this is actually a good idea to be up to date with the developments. So we can propose introducing something like that. Okay, and well, this was basically what I prepared for you. I strongly recommend you to browse through the actual document itself, which I will upload to the wiki page alongside the presentation that I've just given to you, so that at least you have an idea of what kind of different properties you should be looking at on the terminal device that you are using for a test, for example. And if you have any further questions that you didn't ask during the presentation, then please do so now.
Okay, thank you, Peter, for the excellent presentation. We still have quite a lot of time from our time frame. Basically, any question or comment is welcome, which Peter shall address.
Thank you very much for your question. So the question is that are we doing any research in vision science, like the imaging process of the retina combined with holographic displays, for instance, the virtual retinal display? Now, do you mean us as Holographica, or do you mean the ICDM committee? Both. Okay. Well, what I can say for the Holographica side, we don't have such an activity. So we are rather using instruments like cameras and colorimeters to measure the properties of the display. About the ICDM, well, as I don't know everybody in the committee, I cannot know for sure, but at least as far as the IDMS standard is concerned, I didn't see such measurements, because this is metrology, so it completely leaves the human observer out of the game. But there might be, like as you can see, there is a person who is specifically dealing with human factors and vision science, Andrew Watson from NASA. I would suspect that he might be doing something in this area, probably not about holographic displays, but it could be interesting to ask. Does this answer your question?
Okay, currently there is one person writing, and here we have the question.
Okay, that's a very interesting question. So, are there any standardization considerations for the next generation automotive display technologies in 5G systems? Now, I think I would separate these into two questions. Like, you mean metrological standardization in automotive displays? Yeah. Okay. Well, what I can say is that in all the measurements that you can find in the standard, you will also be able to see that what kind of displays the specific measurement is suitable for, because this is also written. And I would suspect that an automotive display is not so much different from, for example, the flat panel displays that one can see, and as such, the existing measurements can be used for characterizing most of the properties of those displays. Now, if there are some special metrics or special considerations about these displays, then those should be addressed separately. I didn't see such an activity at this moment. And about 5G, I think I'm not in position to answer this question.
Okay, in this case, I would like to ask, do we have any further question or comment to Peter? If not, then this officially concludes OSC 4. Thank you again, Peter, for holding such an excellent presentation. Oh, we have a question, it seems, or let's find out. Oh,
Okay.
Kate, it's not a
Thank you very
question,
much
but
for your attention.
all right, thank you again. And basically, see you next week at the same time, the same place for OSC number 3. Thank you again very much, and see you next week.